Recording in progress.
So, in our previous class, we had some discussion on displacement current. Just want to conclude once more time the related theory. Displacement current, physically nothing flows. So, only varying electric field. Displacement current comes into existence, only the electric flux changes with the time. Okay. Displacement current produces magnetic field. As same as a normal current carrying conductor. Which means, for example, if I am taking a circle of some r radius, if I choose a point here, I am noticing that there is a magnetic field B as per right hand grip rule. The same magnitude of the magnetic field I will notice here. Even though there is no physical current. And that contributed current is what we call as the displacement current. Okay, the sum of displacement current and conduction current satisfy the property of continuity of current. These are some theory point which you need to know. Otherwise, you will find a bit difficult in handling these issues. So we will move on to the next part of the electromagnetic waves. I hope I will complete the theory. I hope I will complete the theory by today, by all means. Right. I will discuss problems also later on. Record అవుతుందా? Right. Good. In our previous class, our focus is mostly on what you call energy density, and we have understood as if that energy density is equally distributed between electric and magnetic fields. Do you remember when we are learning waves, mechanical waves? We have gone through certain areas like intensity, power, etc., like kind of thing. Because basically this is wave. For a wave, these are the characteristic parameters. A wave is characteristic by its intensity. Wow, what an intense light. Right. So therefore, basically we need to study the intensity of an electromagnetic wave. And I'm telling you again, mostly in my study, I will take comfort zone, plane wave. We are studying here strictly plane wave. Okay, not complex situations. Intensity of electromagnetic wave. We are strictly working on this right now. Right. What is actually intensity? Already you know this. Anyone in the class? What is intensity? Amount of energy transferred per second per unit surface area normally. Right? Amount of energy crossing per unit area per unit time per unit area of surface held normally to the direction of wave. So all these terms, if I write properly, I is energy, area of cross section into time. For our understanding, imagine I am taking a small cylinder like this, a cylindrical portion of space through which electromagnetic wave is passing through. This is how electromagnetic wave passing through. Say this is of length L, and it took delta t seconds to cross this region, and the cross-sectional area of this region is A. I don't know energy here, but I know energy density. Energy density means energy per unit volume. Total energy density into A into L by A into delta T. Okay. Energy density into L by delta T is speed of propagation of EM waves, which is nothing but the speed of the light. So finally, intensity can be written as epsilon naught ERMS square C. అవును ఈ ఎనర్జీ డెన్సిటీ టర్మ్ వాట్ ఎవర్ దట్ ఐఎమ్ రైటింగ్ ఈజ్ ఇట్ ఓన్లీ ఎలక్ట్రిక్ ఫీల్డ్ ఆర్ టోటల్ కాంబినేషన్ షూర్ రైట్ వై బికాస్ యు నో if it is only electric field it is epsilon naught ERMS square by 2. It is a total picture, right? That is about the intensity of the wave, that's all. Next, what about the other properties? Other properties means intensity I have defined. You said wave carries energy as well as momentum. Let us first discuss about that. Very small points. I'm telling you, this chapter is majorly means oriented. It's like you will have formula based contents. You know formula, you are done. I'll close the theory by today, by all means, another half an hour. That is the reason why I'm recording this. Even before mains also, if you want, you can refer this video. Right. EM waves carry energy and momentum. Okay. And before this, I will add one more term. Suppose if I have a point source, a bulb, an LED, anything, power is equal to P. Now imagine the light from this source spreads symmetrical in all directions. So you can imagine a envelope of a sphere. Now you imagine a point here, which is at a distance R. And let this be point A. What is intensity at A? P by 4 pi R square. P by 4 pi R square. Energy intensity is P by 4 pi R square. Power. P stands for power. P by 4 pi R square. So that is also one relation available for you. Okay. You can use this one also at a later stage. Right. Now electromagnetic waves carry momentum. Suppose Assume U is the energy. EM waves. Right. So the momentum carried by EM wave given by P is, remember that is power and this is momentum. Energy by C. Remember, rest mass of a photon is 0. Rest mass of photon is 0, but still they carry momentum. You can feel the pressure or force exerted by electromagnetic fields. In the process, for example, you met with some surface which is a perfect absorber. In this case, momentum transferred is simply U by C. Because initial momentum is U by C, finally is 0, the transferred path is U by C. Suppose if it is a perfect reflector, what is given in NCERT, that I am uttering, remember. Perfect reflector. If it is a perfect reflector, what happens? If it is a perfect reflector, what happens? It strikes with the momentum U by C and reflects back with the momentum U by C, and the change in momentum is 2U by C. So this is imparted to the surface. I will teach much more qualitatively if we are approaching light as a photon. In modern physics, we will derive everything. Here, even in NCERT also, it is information. Any doubts? Any doubts? Any doubts till this point? Now, since you convinced that they carry momentum, they can exert force also. So therefore, the next topic that I would like to take up at this point is radiation pressure. Radiation pressure. Since you convinced that it carries momentum, నాన్న నీకు సండే వేట గుర్తుందా ఎన్ని వచ్చాయో? తక్కువే వచ్చాయి, అందరికి భయపడాల్సిన అవసరం లేదు, బట్ నీకెంత వచ్చాయి? రేడియేషన్ ప్రెషర్ నేను నిన్న చెప్పిన లెసన్ కూడా రికార్డ్ చేసి ఉంచాను, చూసుకున్నాను. రైట్. When electromagnetic waves is incident on a surface which is either perfectly absorbing or perfectly reflecting, you have noticed that there is some momentum transfer. Agreed? Right. So due to this change in momentum, the surface upon which this incidence is happening will experience a force. Because rate of change of momentum is force. Since change in momentum takes place when incident on a surface. So the surface will experience a force and hence pressure, and this pressure is called radiation pressure. So pressure P is force per unit area, 1 by A times the time rate of change of momentum. But you already know delta P is U by C in case of perfect absorbing surface. Therefore, pressure. Remember, this is not momentum. Pressure. Akkada PA, ikkada ade problem naake ikkada. 1 by A times U by C dt. ఎక్కడన్నా విన్నారు ఇది? U by A dt is intensity. ఇప్పుడే చెప్పారు కదా ఇక్కడ. U, what is this one? U by A dt. I by C. This is for perfectly for a perfectly reflecting surface. For a perfectly reflecting surface. EM waves, we have only two options. We don't work on in-between option. That we will work in quantum physics. Partially reflecting or partially observing cases, we will take care in modern physics. Okay? Right. 1 minute. Very important terms. Only that you need to directly substitute. Nothing else. Okay. One last application aspects, last 1 minute. Right. Application aspect, one more thing that you need to learn, that is Poynting vector. Poynting vector of an electromagnetic wave. Okay. What exactly is Poynting vector? Nothing. I am not teaching anything new from intensity. Just what I am telling is, it is a vector quantity. It shows you the direction along which electromagnetic wave is propagating per unit. It gives you the amount of energy propagating per unit time, per unit surface area. Already I taught you intensity. What is this? The intensity and what is this? This is a vector quantity. So how to define this? It is defined as Okay. Remember, this is a vector quantity. Flow of energy, akkada ilani cheppanu. It is defined as the flow of energy in the direction of propagation of a wave per unit time through a unit cross-sectional area. Perpendicular to the direction of propagation. Because a lot of times questions are given from this concept. Again, I told you this is a formula-based approach. I'll give you information, but this is basically a formula-based approach. Imagine a plain electromagnetic wave. Imagine a situation where light is propagating along x-axis. And this is z-axis. And this is y-axis. So when light is propagating along x-axis, I am assuming this is the electric field vector at an instant and a magnetic field vector at that point at an instant. And this keeps on moving. That's what I have demonstrated yesterday. Okay. Magnitude changes as well as direction changes. Direction change means at this point, the field is in the positive y direction. Some other time, it may be in the negative y direction. During the same time, the magnetic field will be in the negative z direction. Any doubts till this point? Now, imagine a small portion of the space. Small portion of space. Hardly separated by a distance CDT. Hardly separated by a distance CDT. Any doubt till this point? Now, this is how energy is propagating, and I am now defining S bar like that. Because I told you very clearly, S bar is a vector in the direction of propagation of light. And what is the magnitude of S bar means? Energy per unit time per unit area, normally to the surface, right? Now, the question is, in that very small volume, what is this volume? Can you please help me in writing this? Small volume is A into C into dt, equation 1. Any doubts? Energy density, I know it is epsilon naught ERMS square. Or, okay, sorry. Energy density is at that instant is E naught E square. Remember what is the difference between the one which I have written and the one which I am writing right now? That is, this is in statics. And don't worry, it's taking care of both the energies. It is taking care of both the energies because this equation comprises of both electric field component and the magnetic field component together. Any doubts? Sure. That is energy density into C into dt. Any doubts? So what is Poynting vector? A into A. What is Poynting vector? No, what is exactly Poynting vector? 1 by A. Actually, I should not write this as UD. This is UD. Should write this as U only. This part is UD. So therefore, that is Poynting vector. Now help me in writing this. Du by A dt is simply E square C. Array. What exactly I am writing? I am not writing anything new. This is nothing but your. That's all. So therefore, in this case, C can be written as 1 by root mu naught epsilon naught E square. This can be written as root epsilon naught by mu naught. Remember, I am giving you simply magnitude term. That's all. Okay. Or you can write the same thing in a different way. S can further be written as epsilon naught E epsilon naught E. C can be written as E by B. Okay. So one fact, in the place of 1E, I can write C is 1 by root again. So this is nothing but mu naught. Finally. So how to write vectorial? Excellent. S bar is E bar cross B bar by mu naught. This term is Poynting vector. If I take S average value, what you will get? 1 minute. I can write E naught, I can write B naught, I can write sin square omega t minus kx by mu naught, average value of this function. The average value of that function is 1 by 2. So which you can further written as ERMS BRMS by mu naught. But we know how to ERMS BRMS by mu naught. What is the intensity? We have written intensity somewhere here. Epsilon naught ERMS square C. Okay, hold on. So S average is nothing but here your use this relation again. Epsilon naught ERMS square C, which is nothing but intensity. So therefore, the average value of Poynting vector is nothing but the intensity at that place. The average value of Poynting vector is nothing but intensity. What is the objective of Poynting vector? That gives you the direction of propagation of light at that point. S bar main intention is to give you the direction of propagation of wave at that point. Any doubts? So these are some important points that one need to know. That's all. And one more important point, since field is oscillation, some important points, EM wave do not require material medium. Okay. So direction of propagation, C cap is equal to E cap cross B cap. You can use that. So only electric field component only electric field component of electromagnetic waves produce optical effect. When you are seeing someone, it's not the magnetic part. The electric, our eyes responds only to the electric field component of electromagnetic wave. అందుకనే దీన్ని ఏమని పిలుస్తారంటే లైట్ వెక్టార్ అని కూడా పిలుస్తారు. ఎలక్ట్రిక్ ఫీల్డ్ కాంపోనెంట్ నే we will call it as light vector, right? They were not deflected by ఎందుకు లేట్
సార్ ఆటో రోజు
అంటే 7 కి స్టార్ట్ చేసినప్పుడు మీరు చెప్పిన కండిషన్స్ ఏమైనా గుర్తున్నాయా? కూర్చోండి అన్నా సార్, రికార్డింగ్ లోకి వస్తుంది. They were not deflected by E and B fields. Right. So I have given all necessary information. But they exert the radio. Any points, why you require all that I have derived? I am not giving anything. Pointing vector ichanu, intensity ichanu, all that I have given. Okay, one point that I would like to add. Already we had electromagnetic alternating currents. We studied alternating currents. In the medium in which EM waves propagate, okay, offers, I should say a word called hindrance or your impedance. For a wave we call hindrance to the propagation of wave. And this is called wave impedance, Z. You will study this at a later stage, maybe in your engineering if you are in a communication line. And for a medium, Z is given as E by H. H is magnetizing field, not your B. And this is given by root mu by epsilon. It is given as root mu r by epsilon r times mu naught by epsilon naught. For air, Z is mu naught by epsilon naught, and once mains they were asking this question. No student know what is the meaning of this. 376.64. Okay. And one more important point, electromagnetic waves, oscillating fields. So they should satisfy the condition dou square B by dou X square is dou square B by dou square is 1 by C square times dou square B by dou T square, or dou square E by dou X square is 1 by C square for a plane electromagnetic wave, dou T square. So these are the terms. These are minimum required theory points. Now from here, whatever that I am teaching is like a social studies topic. Information, basically. Now see, before this, in this part of the notes, so I have provided NCERT content also. What's all very important, like for example, number of times this question was given as what you call a practice part, or in our grand test also, in an original mains also repeated. Please go through this example. Only highlighted area, just once go through. Once go through. All I have covered. Practically, I have covered everything in this. But still, the highlighted area, because you don't require one more round of reading a NCERT after this class. So I have attached that important NCERT area in this portion itself. Okay, right. So now we will start with electromagnetic spectrum. This is purely NCERT oriented. I told you Maxwell predicted the existence of electromagnetic waves on the basis of his equations. 20 years later, they were produced and detected by Hedge. Later on, the existence of ultraviolet and infrared experimentally observed. No idea about a spectrum by that time. Accidentally, sometime later, X-rays were observed. Even as the science proceeds, experimentally, gamma rays were discovered. So all these are electromagnetic. So therefore, there is a need to make them in a proper order. You know, spectrum is an orderly arrangement of something. As per, according to the wavelength, they were arranged. Okay. So starting from gamma rays, followed by X-rays, followed by UV, followed by visible region, followed by infrared region, followed by microwaves, followed by radio waves, etc. That is the order of wavelengths, shortest to longest. So they have clearly given. One important point is that there is no sharp division between one kind of wave and the next. And in India-Pakistan border, Pakistan-Afghanistan border, this is continuous. Right. Now, you will deal one after the other. For example, you take radio waves. So how are radio waves produced? Radio waves are produced by the accelerated motion of charges in conducting wires. How and all that is not your headache right now. I told you, what all I am giving you is an Ram Kartikeya information. That is the reason why I chapagod that. You learn it in engineering. Right. Radio waves are basically used in communication purpose, radio and television communication purpose. The range of their frequencies are on the order of 500 kilohertz to about 1000 megahertz. AM stations to FM stations. The amplitude modulated band is of the order of, sometimes they will ask this question. Options you need to match 530 kilohertz to 710 kilohertz. So those frequencies whose frequency range is above 54 megahertz. Okay, they are used for short wave bands. In our channels, whatever that earlier when we used to have this cable TV as a criteria, a cable line that comes straight away from somewhere to your house to your TV. During that stage, UHF, SHF బ్యాండ్స్ అని ఉండేవి మీ రిమోట్లో. ఇప్పుడు అసలు అవేం లేదు, బాక్స్ వచ్చేసింది, సెటప్ బాక్స్ డిజిటల్ చేసేస్తుంది అది. రైట్, ఇంకా మరి చెప్పాను కదా, ఇదంతా మీరు 30-40 years కిందట ఇన్ఫర్మేషన్. షార్ట్ వేవ్ బ్యాండ్స్, టీవీ వేవ్స్ రేంజ్ ఫ్రమ్ 54 రేంజ్ గుర్తుపెట్టుకోవాలి, 54 మెగాహెడ్జ్ టు 890 మెగాహెడ్జ్. ఎఫ్ఎం మీకు తెలుసు 88 మెగాహెడ్జ్ టు 108 మెగాహెడ్జ్. సెల్యులర్ ఫోన్స్ అల్ట్రా హై ఫ్రీక్వెన్సీ జిగాహెడ్స్ లో ఉంటాయి, జిగాహెడ్స్. Radio waves to transmit voice communication into ultra high frequency band. Chapter 15 is not there in your syllabus right now. That is communications. So what is that I need to learn from radio waves? How are they produced? So a statement based question can be given. You need to identify. Only once you study this, read this, you will identify. They won't give any problems related to this. It's an informative type. Next, microwaves. They are short radio waves. Radio waves loke vasta microwaves kuda shorter wavelength side. More than infra, lesser than long radio waves. కార్ లాకింగ్ కి మనం వాడేది మైక్రోవేవ్స్. మైక్రో ఓవెన్ మైక్రోవేవ్స్. Okay, whereas while you are using remotes, you are using infrared, and you are using remote, TV remote, AC remote, all that they are infrared, not microwaves, right? So frequencies in the gigahertz range are produced by special vacuum tube called point klystrons, magnetrons, and gun diodes. So source of microwaves, klystrons, magnetrons, and gun diodes. Okay, so because they are very short in wavelength, they can travel for longer distances. So therefore they are used for radar systems in aircraft navigation. Radars are also provide the basis of speed guns used to time fast. Right now you are using speed of the ball, delivery అయిపోయిన 140, 136. How they are telling? Using this system, radar. Okay, tennis, automobiles. Microwave ovens are interesting domestic applications of these waves. In microwave, this is very, 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 very n number of times this yellow area appeared in exams. N number of times. So the frequency of the microwaves is selected to match the resonant frequency of the water molecules. Basically, most of our food items are with water. You prepare anything, samosa, water, puff, water. Microwaves are food, rice, vegetables, water. Some water content will be there. So the frequency of the microwave is selected to match the resonant frequency of the water molecules, so that the energy from the waves is transferred efficiently to the kinetic energy of the molecule. As the molecule's kinetic energy increases, that is nothing but the rise in internal energy or rise in temperature of the system. Okay, that's the principle of microwaves. Next, infrared waves. Infra waves are produced by hot body. Remember, source. Left side box lo infrared, UV. Ila istar. Right side detection istar. Matrix match type mains question. ఒక్కడ మిస్ అయినా మొత్తం పోతుంది మీకు. జాగ్రత్త చదువుకోవాలి. Infrared waves are produced by hot bodies and molecules. We are also source of infrared. This is next to low frequency or long wavelength of visible spectrum. They are also called as heat waves. Right. So basically, water molecule presents in the most material readily absorb infrared radiation. For example, carbon dioxide, NH3 also absorb infrared. After absorption, their thermal motion increases. That is, they heat up and heat their surroundings. Infrared lamps are used in physiotherapy. Physiotherapy they will use. Right. Infrared radiation also plays an important role in maintaining the earth warmth or average temperature through greenhouse effect. See how temperature is maintained on gas. For example, you see on moon, one side the temperature is somewhere around 45, 50, or sometimes 80. The other side the temperature is minus 240. Why? Because there is no atmosphere. When there is atmosphere, what will happen is during daytime, whatever that we are receiving heat and light, that heat is trapped by the atmosphere. And this will help in maintaining an average temperature. But avi takkuva aithe problem, ekkuva aina problem. More high greenhouse effects ekkuva ayipothe meeku emayipotundi temperature average temperature perigipothe ice melt ayipothe sea level పెరిగిపోతుంది. మాన్సూన్స్ మీద సీజన్స్ మీద ఎఫెక్ట్ చూపిస్తుంది. బాగా తక్కువైపోయింది అనుకోండి, టెంపరేచర్ డ్రాప్ అయిపోతూ ఉంటుంది రేట్. డే టైం ఓకే, నైట్ టైం మైనస్లోకి వెళ్ళిపోతుంది టెంపరేచర్. రైట్. The incoming visible light which passes relatively easy through atmosphere is absorbed by the Earth's surface and re-radiated as infra, longer wavelength radiation. This radiation is trapped by greenhouse gases such as carbon dioxide and water vapor. Infrared detectors are used in Earth satellites. You know, infrared cameras are also available. Right. Military purposes and to observe growth of crops. Electronic devices, I just mentioned, LEDs. Your remote, the front part will have an infrared LED through which you will communicate with your TV. Right. Video recorders, hi-fi systems also will have the same. It works on infrared range. Visible. Very simple. What is the source of visible radiation? Electronic transitions. At atomic level, electronic N2 to N1, N3 to N2, N4 to N1, all these transitions will be source for light waves. So nearly 4,000 angstroms to 7,000 angstroms. So our vision is basically because of this limit. Next, ultraviolet, UV, range of wavelength is important. 400 nanometer down to 0.6 nanometer. Ante 0.6 into 10 power minus 9, 6 into 10 power minus, till 6 angstroms. Till 6 angstroms, you will have UV radiation. They are produced by special lamps, very hot bodies. Sun is a source of UV radiation. You already know sunlight contains UV that is majorly filtered by ozone layer, and that is basically protecting us from the exposure of UV radiation. Very hot bodies basically sources for UV radiation. Right. ఇది చూడండి, ఇది ఇస్తాడు. Exposure to UV radiation induces the production of more melanin, causing tanning of the skin. UV radiation is absorbed by ordinary glass, so one cannot tan or sunburn through glass windows. So welders wear special glasses or for face masks with glass windows to protect their eyes from large amount of UV. That you already know. ఇలాంటిది అర్థం పెట్టుకుని వెల్డింగ్ చేస్తాడు. ఇప్పటికీ నేను చూసా, ఎవ్రీ ఇయర్ ఒక క్వశ్చన్ కనీసం ఉంటుంది దీని మీద. లాసిక్ UV radiation can be focused into very narrow beams for high precision applications such as LASIK, laser assisted in situ. అదే నాకు కూడా తెలియదు. ఐ సర్జరీలో వాడతారు, లాసిక్ సర్జరీలో. అలానే మన వాటర్ ప్యూరిఫైయర్స్ లో యూవి ల్యాంప్ ఒకటి ఉంటుంది. దిస్ విల్ కిల్ జర్మ్స్ టు సమ్ ఎక్స్టెంట్. ఓకే, మైక్రో ఆర్గానిజమ్స్ విచ్ కుడ్ డ్యామేజ్ అవర్ హెల్త్. వాటర్ ప్యూరిఫైయర్స్ లో కంపల్సరీగా యూవి ఉంటుంది. ఇప్పుడు నేను ఏమని చెప్పాను వాటర్ హీట్ చేయమని? ఐ డోంట్ మెన్షన్ దట్. ఎందుకుంటుంది దాని పర్పస్ ఏంటి? హీట్ చేయడానికి కాదు, ప్యూరిఫై చేయడానికి. అవ్వదు. హీట్ ప్యూర్లీ ఇన్ఫ్రారెడ్ జోనే. రైట్. Ozone layer in the atmosphere plays a protective role and hence its depletion by chlorofluorocarbons a matter of international concern. మనకు సంబంధం లేదు. X-rays. Wrongton is the first person who produced X-rays actually. Their wavelength is very, very small. 1 angstroms, almost a few angstroms to 0.1 angstrom. Almost of that range. Very, very small. 0.001 angstrom. Very, very small. So anyway, we will study this chapter later on. X-rays production we will study in modern physics. Fast moving electrons, when they strike a target material, they produce X-rays. X-rays are very much helpful at diagnostics, particularly for human beings as well as metals. Flaws avi, metals lo flaws avi find out చేయాలన్నా ఇప్పుడు మనకు కొంచెం 4 రోజులు ఎక్కువ జలుబు చేస్తే వాడు ఎక్స్రే తీసుకురమ్మంటాడు. రైట్. ఎక్స్రేస్ డయాగ్నోసిస్ పర్పస్కి బాగా ఉపయోగపడుతుంది. మెడిసిన్, కొన్ని క్యాన్సర్ ట్రీట్మెంట్స్కి ఎక్స్రేస్ వాడు. అది కూడా చాలాసార్లు అడిగాడు, యూవి వాడాలా ఎక్స్రేస్ వాడాలా? అదో పెద్ద కన్ఫ్యూజన్. ఎక్స్రేస్ వాడతాం, తర్వాత చూద్దాం, ముందు ఎక్స్రేసే. నెక్స్ట్ గామా రేస్. క్యాన్సర్ సెల్స్ డిస్ట్రాయ్ చేయడానికి వాడతారు. మెడిసిన్లో వాడతారు. ఇక్కడ వాడు ఏమని అడుగుతున్నాడు? కొన్ని క్యాన్సర్స్కి ఎక్స్రేస్ వాడతాడు, కొన్ని క్యాన్సర్స్కి గామా రేస్ వాడతాడు. 2 ఇచ్చాడు. బేసిక్గా ఏంటంటే దే ఆర్ షార్టర్ వేవ్ లెంగ్త్స్. క్యాన్సర్ స్టేజ్ని బట్టి ఇనీషియల్ స్టేజెస్లో ఎక్స్రేస్ వాడచ్చు. కొద్దిగా బాగా ముదిరిపోతే కీమోథెరపీ అని స్టార్ట్ చేస్తారు. దానిలో దే విల్ యూజ్ low dosage, lowest wavelength. They are used in a medicine to destroy cancer cell, source nuclear reactions. ఈ టేబుల్ బాగా గుర్తుపెట్టుకోవాలి మీరు. ఈ టేబుల్లో మ్యాక్సిమం మిమ్మల్ని హెల్ప్ చేస్తుంది. రేడియో వేవ్ లెంగ్త్ రేంజ్, ప్రొడక్షన్, రేడియో వేవ్స్, rapid acceleration and detection of electrons in aerials. Antenna basically radio waves. Microwave, klystron wall, magnetron wall, gun diode. Detection, point contact diodes. Infrared, vibrations of atoms and molecules. detection, thermopile, bolometer, infrared photographic film, light. Electrons in atom emit light when they move from one energy level to the low energy level. Mano, eye, photo cells, photographic film. UV. UV kuda source ide atomic but baga first orbit effect kavali. N is equal to 1 దగ్గర effect kavali. Inner shell electrons in atoms moving from one energy level to low energy level. Photocells and photographic film. X-rays, X-ray tubes, photographic film, Geiger tubes, ionization chamber. X-rays ki gamma rays ki mostly same ఉంటుంది detection. Mostly radio nuclear reactions basically. ఇది NCERT information.
Same like it's
ఇప్పుడు చెప్పారు ఆ పైన ఏదో దీని కిందది కూడా అంతే, అందుకని డూ అని రాశాడు. దిస్ ఇస్ ఆల్ ఎన్సీఆర్టీ. బట్ అపార్ట్ ఫ్రమ్ ఎన్సీఆర్టీ ఇంకా నేను కొంచెం ఎక్స్ట్రా ఇన్ఫర్మేషన్ దీనిలో ఇచ్చాను, వేరే అంటే ప్రైవేట్ బుక్స్లోంచి. అది కూడా ఒకసారి చదువుకోవాలి ప్రైవేట్ బుక్స్ నుంచి. దట్స్ ఆల్. సో ఐ హావ్ డన్ థియరీ. So we will work on some numericals. Start. Each of the circular plates of a parallel plate capacitor has a radius of 4 centimeter. The capacitor is charged such that the electric field in the gap between the plates rises at a constant rate of so and so. Right. Each of the circular plates of a parallel plate capacitor has a radius 4 centimeters. My bag mundu Apple pencil into this. I work on this question now. చేయండి. Parallel plate capacitor, radius of 4 centimeters. Capacitor is charged such that the electric field in the gap what is the displacement current? Clearly displacement current is epsilon naught A d by dt. అంతేనా? epsilon naught d phi E by dt. You said epsilon naught area pi into 4 by 100 square into 2 into 10 to the power of 12. Just simply work on that. You will get the desired answer. Next. Okay, any doubts? I'm not putting till the last step. I think that's fine. The voltage between the plates of a parallel plate capacitor is changing at a rate of 10 volt per second. Find the displacement current in the capacitor if the capacitance of the capacitor is 2 microfarad. So how are they related? You know Q is equal to CV as it is mains question this one. So dq by dt is C times dV by dt. So 2 into 10 power minus 6 into 10. So 20 micro amps. Any doubts? Clear? Next. A parallel plate capacitor is having plate area equal to A and a constant current I is flowing to charge the capacitor. Consider a circle of radius R parallel to the plate of the capacitor. Find the displacement current through the surface enclosed by this circle. Simple. You want the displacement current only through that portion, not full. Right. Pi already చేశాం కదా నేను. You have this relation. B కట్టడానికి. So how to find the displacement current? Epsilon naught, that area which you have selected. dE by dt. Okay. But how do I know these things? Electric field is Q by epsilon naught A. dE by dt is 1 by epsilon naught pi r square I. ఏరేచాడా? Yeah. This is equation 1. So therefore, this is epsilon naught pi r square dE by dt means 1 by epsilon naught A I. The displacement current is pi small r square by A times I. Any doubts? Ram Karthikeya, do you have any doubt? Any doubts? Any doubts? Right. Mahalakshmi, any doubt? A parallel plate capacitor has two circular plates, each of radius 5 centimeter, separated by so and so distance. Capacitor is charged by an external load and a constant current of 6 amps is delivered to it. Find capacitance. Epsilon naught A by D gives you capacitance. The rate of change of potential difference across the plates. Q is equal to CV. Current is equal to C dV by dt. The displacement current. This is the displacement current. Why not?
అది మళ్ళీ పైన వచ్చిన ఫామ్ లో
నువ్వు అడుగుతున్నది ఏమి సర్టెన్ ఏరియా అని ఏం చెప్పలేదుగా. అప్పుడేమవుతుంది? ఫైన్ ఫార్ములా ప్రకారం ఏరియా ఫుల్ ఏరియా అయితే displacement current is same as, in this case is simply I. Any doubts? Any doubts? Boys and girls, any doubts? Any doubts? Right. Work on this point charge having right. Point charge having charge of magnitude q is traveling in a straight line with a constant speed v. Consider a point on the line of motion of charge towards which charge is approaching. Assume a very even this question also given in mains. Assume that the charge is moving small area. Calculate the displacement current associated with this is distance r. Electric field there is 1 by 4 pi epsilon naught q by r square. Flux is 1 by 4 pi epsilon naught q by r square. A is the area of that small portion. So displacement current is epsilon naught d phi e by dt. Epsilon naught 1 by 4 pi epsilon naught q into a d by dt of 1 by r square. So this can be written as q into a by 4 pi minus 1 by r cube times dr by dt minus 2 by r cube dr by dt. So minus dr by dt. So therefore qa by 2 pi r cube. That's the expression for displacement current. ఇది కూడా వచ్చింది మెయిన్స్ లో. Ask me any doubt. Do you have any doubt? Tasya, do you have any doubt? Clear? And the last. Capacitor of capacitance is connected to a battery of EMF V through a resistor R with the switches connected in series. I don't care all these things. What is the current in this? T by RC. Growth of the charge case current expression. Yes or no? Boys and girls. Displacement current ante ide the displacement current is the same as I. You are not asking any special area, etc. like kind of that is displacement current. Any doubt? In those thoughts. And this side, this displacement current is the same. Any doubts? That's all. Done. Basic models. Okay. Now, any other points, for example, if I notice any other point apart from this, I'll leave only one page here. Right. Any other, if I miss, for example, I'll fill it there. But theory point of view, I am done. Okay. What I suggest you is read the entire notes today. Now the time is 9:30. Till 10 o'clock, you read the notes. Everyone. Right.